Which of the following straight lines are both tangent to the circle? Given a circle, I have a circle, I want to find center and radius. Hardwired like that. Fine, so let's do this. This is x square minus 6x plus 9, y square plus 4y plus 4 equals 9 plus 4 plus 12. What am I doing here? I'm completing the square. X square minus 6x plus 9 is a nice square. I have 9 here, I'll put 9 there. Y square plus 4y plus 4 is a nice square. I have 4 here, I'll put 4 there. I take the minus 12, put it that side, it becomes plus 12. Or this is x minus 3 the whole square plus y plus 2 the whole square is 25, which is 5 square. Or think about it, the center is 3 comma minus 2, radius is 5. Square root of 3 square plus 2 square is square root of 13, 3 point something, so this goes out. A circle like this. Center is 3 comma minus 2, radius is 5. Now, which of the following straight lines are both tangent to the circle? Two straight lines. And so 4x plus 3y plus 19 equal to 0, 4x plus 3y minus 31 equal to 0, plus 19 plus 31, minus 19 minus 31, minus 19 plus 31. All combinations of that. 4x plus 3y is the line. So it's a line like this or a line like this. How do I find this? Suppose hypothetically I assume a line, a tangent line to be a line like this. Then this tangent is perpendicular to radius. So from center of the circle, if I draw a line to the point of tangency, that should be perpendicular to that, and we can find the perpendicular distance. What am I going to do? I'm going to take this 4x plus 3y plus 19 equal to 0 and find the distance from 3 comma minus 2. So 4x plus 3y plus 19 equal to 0 from 3 comma minus 2. What is this perpendicular distance? 4 into 3 plus 3 into minus 2 plus 19 by square root of 4 square plus 3 square under modulus. 4 into 3 is 12 minus 6 plus 19, 12 minus 6 plus 19 divided by 5. 6 plus 19 is 25, 25 by 5 is 5. Yay, brilliant. So, hey, 4x plus 3y plus 19 is definitely a tangent. 4x plus 3y plus 19 is definitely a tangent. So this is in, because distance from the center, perpendicular distance from the center of the circle to this line is equal to the radius. So from here, if I draw a line perpendicular to this line, that distance happens to be 5. So the point of intersection of the perpendicular lies on the circle, or the radius is perpendicular to the tangent at the point of tangency. This works. So it is one of these two. My gut feel is it has to be this, because 4x plus 3y plus 19 equal to 0 has to be a line this side. So 31 should be minus on that side. Let's check it out. This works. So I'm going to check this first and then come to this. 4x plus 3y minus 31 equal to 0. I'm comparing from 3 comma minus 2. This perpendicular distance is what I want to calculate. 4 into 3 minus plus 3 into minus 2 minus 31 by square root of 3 square plus 4 square under modulus. 12 minus 6 is 6, 6 minus 31 is minus 25 by 5 under modulus equal to 5. Very first one, it worked. What you're doing here, from center of the circle, finding the distance to this line, perpendicular distance. From center of a circle, perpendicular distance to a straight line, if it is equal to radius, then said straight line has to be a tangent to the circle. So plugging that in and then simplifying it through choice A.